So, hi everyone. I think that I have an hour to talk about KYBELE, so thanks. So, KYBELE is a joint project between ELIXIR Greece, ELIXIR Switzerland, and ELIXIR Italy. As you can see from its huge logo, it's an AI tool that deals with literature and knowledge extraction. Before that, the current situation in biodiversity data is that we have a lot of data out there published, but there's also crucial information that is trapped in full texts. And this cannot be machine actionable. There is a lot of inconsistencies for habitats, trophic yields, and threats, and we have synonyms and different taxonomy systems across backbones. And generic LLMs can help us extract some information, but they are not quite reliable for science without vocabularies, provenance, and evaluation curation. So the goal of the project is to build an AI-powered fair compliance system that extracts and links biodiversity knowledge from literature. For this short-term project, we use as demonstrator European soil invertebrates, Collembola and Oligoechita. These two groups have a lot of information published, and the project team has expertise on these groups. The project has 4 phases for its implementation. The first one is the data harvesting. In this phase, we get DNA barcodes from BOLD along with their metadata. And then we manually find taxonomy synonyms, find alternative writings for threats, trophic yields, and habitats, and then combine and cross-check with other backbones. And the outputs of the phase 1 is a fair domain-specific curated dataset and terminology rules for habitats, trophic yields, and threats. We are almost done with the phase 1, but the dataset will be published later in 2026. The second phase is the annotation of BiodiversityPMC. We use the terminology from the previous phase in order to build structured domain-specific vocabularies and then annotate BiodiversityPMC in order to normalize its terms in the corpus. And some semi-manual curation might be needed. The third phase is to set up our LLM. We will utilize a pre-trained large language model, and there are a lot of out there. We will use retrieval augmented generation to retrieve information from BiodiversityPMC through APIs. It will be able to perform Q&A, and the fine-tuning will be done through lightweight fine-tuning through LoRa and benchmarking based because we try to keep low computational footprint. And the last phase of the project is to deploy everything, but before that, we will make some final evaluation of our results, and we will run some predefined scenarios, and we will get some feedback from scientists, and then we will containerize the service and deploy as an online service on LifeWatch ERIC and ELIXIR Europe ecosystem. And we will publish everything on open repositories with very descriptive documentation. The impact of the project is that we will get faster and holistic access to biodiversity knowledge. And we will get a tool, a model that is, we hope to be trustworthy. And at the end of the project, the final months of the project, we will explore more capabilities to expand the functionalities. One is to add Darwin core formats. And it will be scalable because as new literature is added to BiodiversityPMC, it will be able to extract it. And we can expand the taxonomic groups that it uses. So, thank you.